we're going to start getting into not quite the proofs that we're going to dive into later this chapter, but we're still going to be discussing the types of angles and lines that you guys learned in the computer lab the other day. So let's review a little bit of those types of angles. So the 5 angles formed by 2 lines and a transversal, regardless, I'm going to write up here because some people don't quite understand this, regardless if the 2 lines, we'll say, are parallel or not. So you don't have to have parallel lines to have alternate interior angles. When you have parallel angles, there's something special about those alternate interior angles. So just keep that in mind. Alternate interior angles look like this. We're on the interior of our 2 lines, and we're on alternating sides of our transversal. Again, when we have parallel lines, there's something special about these angles. When they're not parallel lines, then that thing is not there, that special property. Alternate exterior, same idea. It's alternating on the transversal. One's on the left, one's on the right. They're on alternating sides. And we're on the exterior of our 2 lines. There's the outside. Next, come on, next. There we go. Same side interior. We are on the same side of the transversal, either both on the left or both on the right, and we are on the interior of our 2 lines. Same side exterior, likewise, we're on the same side, so either both on the left, both on the right, and we're on the exterior of our 2 lines. And then the name really didn't give it away, corresponding, is technically it's on the same side of the transversal, except one's interior and one's exterior. And the way I like to think about it was playing, grab this here, well, maybe not, I don't know. Being at the mall, let's say, and here's the second floor up here, and here's the first floor. If I were at shop number 1 and I went down the escalator, then I would be at shop number 5, and those are corresponding angles. And now I've completely screwed that up. There we go. So that is the idea behind corresponding angles. So those are maybe the more difficult ones to identify because the name really doesn't give it away. So here were some other main points that you guys learned about in the computer lab. That when 2 lines are cut by a transversal, and when they are parallel, when we know that they are parallel, then there's something special that happens to 3 of our kinds of angles, the alternate interior, the alternate exterior, and the corresponding angles that are present in that scenario are all congruent with each other. Okay, the alternate interiors are congruent, the alternate exteriors are congruent, and the correspondings are congruent. I'm not saying that the alternate interior angle and a corresponding angle are the same necessarily, but alternate interiors match, alternate exteriors match, corresponding angles match. So instead of writing 3 separate statements for each one of those types of angles, I just kind of lumped them together into one. Now the other 2 types of angles are same side interior and exterior angles. In the presence of parallel lines, aren't congruent, but they are supplementary, meaning they add up to be 180 degrees. So one way I easily remember the supplementary part is supplementary begins with S, and what other angles begin with S? Well, same side and same side, interior and exterior. And everything else that doesn't begin with an S are the congruent angles. Now, on the flip side, when we did not have parallel lines, we still had the names alternate interior, alternate exterior, and corresponding. However, they are not congruent anymore with themselves. Corresponding angles are not the same when we don't have parallel lines. Likewise, when you don't have parallel lines, then same side interior and same side exterior angles will not be supplementary with each other. Okay? So when you have parallel lines, you've got magic happening. When you don't have parallel lines, the magic's not there. But the names of those angles still exist in both scenarios of being parallel or not. Now, one more little thing before we start doing some examples. Just like segments and angles had congruent markings, parallel lines have markings to say, hey, look at us, we're parallel. Now, there's a couple different things you might see. More in class, I use more just like the arrowhead notation here. Sometimes in the book, though, they use a filled-in triangle look. Now, if you notice, there's different numbers of these markings. So I'll just use this example over here. Since this has 1 marking and this has 1 marking, we're saying these 2 lines here are parallel. And since these 2 have 2 sets of markings, I'm saying these 2 are parallel. So since this set and this set have different numbers of markings, not all 4 of these lines are parallel to each other. Okay? There can be more than 2 parallel lines. You could have 3 lines that were all parallel to each other. And each one of those 3 lines would have to use the same marking. Okay? So now let's look at a couple of examples together. So determine the values of angle 1 and angle 2. So looking at this poorly pixelated picture here, I can see, look, there's one filled in triangle there, and it's kind of tough to see on your paper since it's just black and white, so you don't really see the color here. But the parallel markings won't be at the ends because those represent the line aspect of what we have going on here. So they'll be somewhere in between if they are parallel. So here's one marking, and it doesn't have to be on the same level on the other line. It's further down here. But since both of these have the same number of filled in triangle marks here, then these 2 lines are parallel. Likewise, here's 2 markings and there's 2 markings. So therefore these 2 lines are parallel to each other. So we have 2 sets of parallel lines going on here. Now the only angle we know from the beginning is the 64-degree angle. And so let's just start with angle 1. Well, what type of angles are the 64-degree angle and angle 1? Well, if you can see it, great. If not, for a while, you may need to tilt your head sideways or turn your paper sideways. And we said, all right, well, there we had some parallel lines. And, hey, look, there's a transversal. So we're kind of ignoring this other transversal over here for the time being. But if we look at these angles, well, they're on alternating sides, and they're both on the interior, so they're alternate interior angles. And we said that alternate interior angles are, in the presence of parallel lines, which we have, are congruent, So angle 1 equals 64 degrees. And just for the time being, I'm just going to write a reason why I know this is true. We're not really going to have to do proofs like this, but this is just a reason, an explanation of why we know this is true. So I'm just going to say, quite simply, because angle 1 and the 64-degree angle are, and here I'm going to do some abbreviating, are alternate interior angles with parallel, my pen will work here, there we go, with parallel lines. Okay, so I'm using that justification there. Since I have parallel lines, I have alternate interior angles, therefore they are congruent. So 1 is the same as 64. All right, perfect. So let's put that in here in my picture. 1 is 64 degrees. Now I need to figure out what angle 2 is. Well, the 64-degree angle with angle 2, there's not really any kind of special relationship with those 2 angles. So I can't really connect them together. But you know what? Angles 1 and 2, they're adjacent to each other. Is there anything special about angles 1 and 2? Do they have a special name with each other? Hey, they do. What do you know? Angles 1 and 2, if we use these parallel lines, the other set, and we use this line as our transversal, they're same side interior angles. And we mentioned earlier that same side interior angles in the presence of parallel lines are supplementary. So we know that angle 1, which is 64 degrees, put this in parentheses right above it, angle 1, which is 64 degrees, plus angle 2, which is what we want to figure out, must equal 180 degrees. So if we subtract 64 degrees over, we get that angle 2 must be 116 degrees. And we're done. Okay? So again, I'm not going to write an explanation for this one, but you can see why that works. Angles 1 and 2, we have parallel lines. Therefore, angles 1 and 2, which are same side interior angles, must be supplementary as a result. So now I can do the math for it. The second example we're going to do together. A little bit different because we don't just have regular old parallel lines and a transversal. Now we might start seeing more geometric shapes that may have some parallel lines associated with them. So, we kind of see, I'm going to point out the obvious, what most of you are seeing. We got a triangle here. We've got a ray that kind of shoots out this way and a ray that shoots out that way. They don't really make triangles, but they're trying to make triangles like we have over here on the right side. So what I recommend doing is I will take my parallel lines here, right? This guy and this guy are parallel. So all I'm going to do is just use your pencil or whatever you have here, and I'm going to make these things longer than they really need to be. there are my parallel lines. Here's where the magic's going to start to happen. Okay? And now in this scenario, there are two different transversals we could use. We could use this guy right here as a transversal. And I'm making this longer. Notice I'm making it longer than it really is in the picture, but just so I can see that nice full transversal kick in. But there's also another transversal, this piece right here. And again, I'm going to make it longer than it really is, so I can see that nice full transversal and all the angles that it creates. So here's where we kind of need to look at maybe one transversal at a time. And some of you I know are maybe a little like, I'm having a tough time seeing this. So I'm just going to turn the problem sideways so we see our parallel lines like we typically would, stereotypically, being horizontal, which is fine for now. All right. So one thing some people might say is, oh, well, the 70 and the y, those are same side interior angles. Well, they certainly look like it, right? They're on the same side of this red transversal. They're both on the interior of these, but they're not quite same side interior. The y with the 50 all together, because we got to kind of ignore this green transversal because we can only look at one transversal at a time in any given problem. So it's really the 50 and the y with the 70 are same side interior. So we could do something with that, couldn't we? So let's do that there. The 70 and really both of these angles combined. So the 70 and the 50 plus y, they got to be supplementary, right? Because these were parallel lines. Therefore, they must be supplementary. So let's see, 70 and 50 makes 120 plus y equals 180. Subtract the 120 over, and y is, hey, it's 60 degrees. All right, we got somewhere to go where. Now for x, couple different things you could do here. Number one, you could say, you know what, forget about all the parallel line business. Forget about that upper one up there. I see something going on here. Let's use this red transversal as a straight line, and let's focus on that the 60, the 50, and the x all together make this straight line. Therefore, that is 180 degrees. So one way to get x would be to say that the 60, the 50, and the x, using the straight angle postulate, all make up 180. There's 110 degrees accounted for right now. Therefore, x must be the leftover 70 degrees. Now, another thing we could have used, besides using the straight angle postulate in this example, was that x, let's unhide x here, x and the 70 degree angle, notice if we kind of get rid of the green transversal here, doodle, 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 the 70 and the x are corresponding angles. Okay, this is in the lower left-hand corner of this quadrant. This is in the lower left-hand corner of this quadrant. They're corresponding angles. And in the presence of parallel lines, corresponding angles are congruent. So if this angle is 70, x must be 70 as well. So what you're going to find out is there will definitely be more than one way, usually, that you can figure out certain values of certain angles. To begin a problem, there might be only one way to start out with. But as you get moving through a problem, you're going to start to notice there might be 2, 3, 4 different ways to get an angle. So always keep your options open. Now, well, could there have been a different way? Could there possibly have been a different way to get y first besides what we did? Could have been, maybe. You guys can think about it, explore it. See if you can figure out, was there a different way that we could have gotten y, the 60 degree angle, other than the way that we did it with the same side interior angles? I'll leave it up to you. We can discuss it tomorrow. And the last example, I want you guys to try this one on your own. Now again, this is what I want you guys to think about. You think like, oh, well, here's a trapezoid. Well, great. And here the top and the bottom are parallel. What I would recommend doing to start this problem out is to extend the lines out so that you visually kind of see those parallel lines at play. There's the parallel lines. Well, what do the other two sides represent? They represent separate transversals. So you might need to consider like, oh, well, let's just look at this side of the problem. Let's look at that side of the problem and see if you can figure out what x and y are algebraically. You don't have to do any kind of proof for this. You don't have to provide any justification. But we will discuss this one. And I believe there's really only about one way to really figure all this out. It could be a couple different ways now that I think about it.